Hello. We're going to do number 28 right now as a class. So when I look at number 28, this one looks kind of weird because you see how it's like sine 35 degrees and 50, and then all of a sudden this, it's like, are these like terms? Can I subtract these? No, because in order for that to happen, this needs to be sine 35 degrees over here and also cosine. Then we could subtract them, but right now we can't. So I'm kind of stuck until I open up my little formula sheet and I start analyzing some of the things that we see on this. Okay, so if I go up here and let's say up at this part, I see something that's a little bit familiar in the sum and difference formulas. So let me go back. Let me go back and forth here. So I see that it's sine of some angle, cosine of a different angle, minus cosine of that same angle, and then sine of that different angle. So if I look back here, so it's sine, cosine, minus cosine, sine. So do you guys see how we're going to be looking at this little formula right here. So then if it was minus right here, then that means that it's got to be minus over here. So I'll go ahead and transfer that. I'll write that formula over on this side. So it was sine, and then you had alpha minus beta or something like that. And then it was sine of alpha cosine of beta minus cosine alpha sine beta. Okay, so look, check this out. This portion that's right here is this portion that's right here. Does that make sense? Okay, so that means that it's just the addition and subtraction formulas written in a different way. So we can just substitute these values. So what is alpha in this case over here? 35, right? Okay, so that's going to be sine 35, and then we have to put minus because this is a minus right here, okay? So minus the 50 degrees. And so that's what this one equals. So if we go ahead and subtract them, then that'll end up being 15 degrees, right? Negative 15. So then we have sine, this equals negative sine of negative 15 degrees. Okay, so that would be the answer for that one. Now this one's going to be the same story, but see how it's cosine, cosine, then sine, sine? So if we look back over here, I think you guys should try it. It's cosine, cosine, sine, sine. So just watch out. Whenever you're doing the cosine addition formula, if it's adding right here, then that means you have to subtract over on this side. Okay? So adding right here means subtracting over here. Subtracting right here means that you're adding them over on that side. But I'm going to continue on, and let's jump down and do number 29. Now 29, it says find cosine of the half angle. Now on this sheet that I gave you guys, it didn't really show the half angle formulas in a proper way. Okay, it's all weird like that. But the formula sheet that you're going to get on the final, which is somewhere, okay, you will have the half angle formulas, and it looks like this. So I see that we have cosine of the half angle, so it's 1 plus cosine divided by 2. So I'm going to go ahead and write that down. So the formula for a half angle, so cosine of a half angle, is plus or minus the square root of 1 plus cosine of the angle divided by 2. So let's read what's given and try to understand, and just all we're going to do is just throw these things in here. Okay, so it says cosine of the angle is 4/5. Okay, and then it says find this and assume that this is in between 0 and pi over 2, which is the same as 90. So that means that it's in the first quadrant. Okay, so since this is in the first quadrant right here, I know that cosine will end up being positive because this is positive, positive, right? So that means I don't have to worry about plus or minus. I know it's going to be positive. Okay, now 1 plus cosine, well, it tells me cosine. It says cosine of the angle is 4/5. So I'm going to just put 4/5 right here. Let me show you what a common mistake is. When you guys are putting these into this formula, I see some people do this. They go, okay, square root of 1. Okay, I've got that down. And they say plus, good. And then they go cosine of, oh, what is it again? Oh, 4/5. And they put 4/5 right here. Okay, now that's wrong because we can't do this, right? This is cosine of the cosine, and that's not correct, okay? So cosine of the angle is that. All right, now there's one more thing we got to put down there is the 2, and this goes all the way down. All right, so now we just simplify. So right now that 1 has a denominator of 1, but we need it to be a 5. So I'm going to multiply this by 5 and multiply the top by 5. Okay, so 5 plus 4, that's going to give me 9. 9 over 5 is up top, and then divided by 2. Now whenever you're dividing by 2, like this in a complex fraction, we're just going to multiply by its reciprocal. So the reciprocal of 2 is 2 over 1. Give me red. Okay. So I'm going to multiply this by 1 over 2. So I'm just kind of back flipping it up. Okay. So the 9's going to stay up there, and then 10's going to be on the bottom. So to simplify this, we have the square root of 9 over 10. Okay. We could break this up and say that's the square root of 9 over the square root of 10. And if we rationalize, meaning we have to multiply the top and the bottom by radical 10. Hey, what is the square root of 9? Isn't that 3? So we're going to have 3 radical 10 divided by radical 10. Or, excuse me, not radical 10, 10. So that's how you do that one. Kind of crazy, but not too bad. Okay, number 30. It says sine, and then it says find sine of the double angle. So I'm going to go back here, and sine of the double angle is, I believe, down here somewhere. Okay, so sine of the double angle is this guy. So 2 sine cosine. So let's go back, and I'm going to draw the scenario out here. Okay, so the scenario is that its sine is given, and then it says assume that it's in between pi and 3 pi over 2. So this is 180, and this is 270. Those would be good to remember, okay, because you'll see these radians a lot. Okay, so if I'm looking at this, it's somewhere down here. So if this thing goes down like this, I know sine is opposite over hypotenuse, which is 13. So we need to figure out what this is. So in order to figure out what this value is, it's some x value, but since it's in the third quadrant, I know it's going to be a negative x value. So I just do a squared plus b squared equal, or I'm sorry, a squared plus b squared equals c squared, right? So basically 169 minus 25. So 169 minus 25, that'll be 144. Square root of 144 is 12. So this is negative 12. All right. So now remember the formula for the double angle. So sine of a double angle is 2 sine of the angle cosine of the angle. Okay, so we're just going to substitute in the values. The 2 is going to stay there. Now sine of the angle, we already know. Sine of the angle is equivalent to this. So I'm going to multiply by negative 5 over 13. And then cosine of the angle, now that we drew our scenario, we can see from this angle here, cosine is going to be negative 12 over 13. So times negative 12 over 13. Then we just multiply. So 2 times 5, that's going to be 10, or negative 10. Negative 10 times 12 will be positive 120, divided by 13 times 13, which is just 169. Okay, so that's the answer there for that one.